All right, so over here in 2.3, we're going to be talking about something we call Venn diagrams. And this is actually the little pie graph that's on page 12 of the workbook. Okay. And what we have here is a standard little pie graph that has 4 different sets attached to it. We have the set, and these are sets of Spanish speakers, or U.S. Hispanics. Okay. So these are all sets of U.S. Hispanics. We have one group that at home they speak Spanish. So this represents a set of people who speak Spanish at home. So a set of U.S. Hispanics who speak Spanish at home. All right. Then we have another set of U.S. Hispanics who speak English at home. Then we have the set of U.S. Hispanics who speak both English and Spanish at home. All right. And then we have another set, a very small set of U.S. Hispanics who speak another language. Right. All 4 of these sets together describe the set of U.S. Hispanics, everyone. And when we're talking about an entire set of a group, okay, we call this our U or our universe. Okay, so how we go ahead is we usually go ahead and have some circles, and then we have this thing called the universe. And we're going to go ahead and look at that. And this is what a Venn diagram looks like. Okay, so this is your Venn diagram. Okay. Your Venn diagram is always going to have this box around it that represents your universe. Okay. And then you're going to have a couple of different sets inside. In this case, we have 2. I have set A and set B. Okay. And then I also, for this particular group, have a set that overlaps. Okay, so in this case here, I have example 1, and I have already gone ahead and set it all up. So I went ahead and separated into different sections. So section 1 is, and section 2 where they overlap, section 3 and B, and section 4 is your universe. Okay, so things that don't apply to either set A or set B. So anything that sits here in your universe is not part of the other 2 or 3 whatever sets that you have on the inside. Okay, so what I want to look at, I want to know what constitutes set A. Okay, set A is going to go ahead and consist of these 3 letters. So A, B, and C. But remember, D here is in both. It sits in the circle of A, okay? So it also represents D. Now, when we're going ahead and listing our elements, we got to make sure that we go ahead and put our braces in there. So the set A of this particular group of Venn diagram is A, B, C, and D, okay? Part B is the elements in B, not in A. So the sets in B that are not in A. Okay, so in B, not in A. Okay. Now remember D here is also a part of B. Okay, but it's also sitting in A. So the only element that's in B and not in A is going to go ahead and just be E. Okay, so wherever it overlaps, this overlapping section here, okay, if you're doing one set or the other set, you can't go ahead and include that. I know it's getting hard to read now. All right, I want set of elements in U that are not in A. So sets of things that are in the universe, but not in A. Okay. Well, we know this F and G here are not in A. Okay, so we know F and G are totally a part of that. But also remember, everything that's in this box, everything in this box here, in this Venn diagram, is part of the universe. Okay? So F and G are not in A, but also anything that's only in B is also not in A. So E is also a part of that. Everything that's in the box belongs to the universe. So we're looking at everything that's just not in A. All right? Now, if we look at the set of the universe that are not in A or B, okay, then the only things we're looking at is this F and G here. Okay, so the sets in the universe that are not in A or in B are just F and G. Okay, so one thing about sets or Venn diagrams, you can have a couple different ways that can be represented. Okay, if I go ahead and I have a universe, and I have two circles, but they do not overlap, these are disjoint, meaning they're going to have absolutely nothing in common as far as with each other. So this A and this B will have nothing in common with each other, but they all belong to the universe. Okay. If I go ahead and have a universe, and I have a set, and the other set is entirely inside this other set. So if I have set A and set B is entirely inside set A, and there's my universe, okay? This is a proper set, okay? If I go ahead and have my universe, and I have a circle that represents set A, and I have another circle that represents set B, these are equal sets. They're the same set. The circles will overlap. Not horribly interesting for a Venn diagram. And then, of course, we have the one like we just did with the example, where I have one set A, a set B, and the universe, and they have a little bit of something in common. It could be a little, it could be a lot, we don't know. All right, and so this is the most common Venn diagram you're going to have for, for sets, is this idea of where they overlap at some point. All right. I want to go ahead and look at something called intersection and complement. All right. And anything I didn't do, you can go ahead and check out for yourself, but it's all pretty much the same thing. So if I talk about this thing called a complement, okay, so the complement of set A is notated by A and a little comma there, okay? And so this is a complement. All right, and these are the set of elements that are not in A. Okay, so anytime you see that complement, all right, you're looking for everything that's not in A. Okay. And they give some little set builder notation for you that A complement, I'm just going to kind of explain it, is the set of all X such that X is in our universe and X is not contained in A. Okay. More just remember that when you have a set A, the complement is everything that's not in set A. It's much easier to remember than worrying about this fancy notation. All right. I'm going to look at a couple examples. I'm going to have a universe here. Going to be A, B, C, D, and E. It got dark. Why my thing get dark? Okay, there we go. And that's my universe. And I have a set A that is C and E. Okay, and this is not exactly the same as example 3, but it's very similar. Okay, and I want to find A complement. Okay, so A complement is going to be all the things that are contained in the universe that are not in A. So I have A is not contained in A, B is not contained in A, and D is not contained in A. So my A complement is going to be A, B, and D. Okay? I'm going to also look at example 4. Okay. Universe has the elements 1, 2, 3, 4, 5, 6, and 7. And I have A is 1, 3, 5, 7. B is equal to 1, 2, 3. C is equal to 2, 3, 4, 5, 6. Okay, and all of those are contained inside of our universe. Nothing goes lower than 1 and nothing goes higher than 7. Right? So if I want my A complement, I want all the elements in the universe that are not in A. So 1 is already there. 2 is not. 3 is in there. 4 is not. 5 is in there. 6 is not. And 7 is in there. So my A complement is 2, 4, 6. If I want to look at my B complement, I'm looking at all the things that are not in B. Okay. B is consisting of 1, 2, 3. So anything in the universe after 3. I have 4, 5, 6, and 7. Let's go ahead and take that further. Let's look at C complement. All the elements that are in the universe but not in C. Okay, I only have 2. I have 1, because there's no 1 here, as we start off with 2, and 7. Okay, so that's what A complement looks like. All right. We're going to come back and talk about intersections and unions. Go ahead and practice this a little bit. I highly recommend, as we're going through the different symbolism, to go ahead and write yourself a little chart or non-note card or something so you can keep all the different listings together. See you in a little bit.